Okay, so I want to just go through a few of these to make sure that you're on the right track with these homework questions. So number one here, this one's saying, so if you've got this function where you know x is, let's say, equal to -2, and y is equal to -3, or f of x equal to -3, same thing. If you kind of sketch that out a little bit, that would be something like, I don't know, it could be like that, where x was -2 and y was -3. Well, the absolute value, like we were shown before of this thing, would be like flipped before it went over to be up here. So instead of -3 up here, that would just be +3. So if we were making a table of y is equal to the absolute value of f of x, then that's just going to be +3 there. This one's going to be +1. These are going to be the same. That's still going to be 1, that's going to be 3, and that's going to be 5. Just need to make sure it's positive when you say the absolute value. That's all you really need to make sure. Um, when it's 0, it would still be 0 too, because it's allowed to be 0. All right, moving on. Oh, just wait. So the graph of f of x has an x-intercept of 3 and a y-intercept of -4. What are the x-intercepts and y-intercept of the graph of the absolute value? So the x-intercept is going to be the same. That's going to be our invariant point, right? Where it's going to go down and then back up again, right? But now instead of our x-intercept being down here at -4, now it's up here. It's been flipped, right? So it's going to, instead of -4, it's going to be +4. Okay, copy the graph of this on the same set of axes. Sketch the graph of the absolute value. So the absolute value of this is going to be the same, but it's just going to be on the top. It's going to be reflected upward on the x-axis. This one, again, at that invariant point, it's going to reflect upward instead. If I was better at drawing that, that should be more symmetrical than that. More like up and down like that, yeah. Okay, this one can be reflected that way. That should have crossed right at, looks like 3. There we go. Okay, for 6A, let's say, if we had a little table started, then first off, let's figure out like what some numbers are here. So I could figure out what our y-intercept is here if I just put a 0 in place of x. So that would be 0 there. So that would be -6 is what our original function would be. But since it's the absolute value, it's going to be +6. So x-intercept's going to be up there. What would our our y-intercept's up there at 0, comma, -6? What would our x-intercept be? Well, that would be when y, let's just do this, 2x minus 6. So when y is equal to 0. So, and I don't really need the absolute value bars anymore because it'd be the same for either one, whether it was the negative or the positive version. It's that invariant point, same for both. So let's go 2x minus 6. And then solving for that, we'd have x is equal to 6 over 2, so x is equal to 3. So this is going to be at point 3, comma 0. So we've kind of got, we know this is going to do something like this, and then probably go on up here. But let's just figure out what one more point is. So let's put 4 in place of x and see what we get out. So if we did that, we'd have, well, starting out with y is equal to the absolute value of 2. And let's just put in, like I said, 4. We can figure out what one more point is. Minus 6. So y is equal to 8 minus 6, so 2. So y is equal to 2. So at this point right here, this is going to be 4, comma 2. So now we have enough that we've just sketched all that without even putting it in our calculator, right? Now, state the intercepts and the domain and range. So the domain of this thing, the x is any real number. That one's, let's put D for domain. And then the range is going to be y needs to be greater than or equal to 0, like they pretty much always are. Okay, and you guys can go ahead and do B on your own there. So let's look at 7 though. These ones, anything that's below the x-axis just needs to be reflected above the x-axis. So this would look like that. This one would look like that. And then that would also be part of it. This one would look like, as I go up 4, like that. Okay, looking at these ones here for 8, let's do C. So make it green, I guess. And then let's just graph this thing. So I'm going to go absolute value and then negative 2 x squared minus 3x plus 2. Okay, we get that Wu-Tang symbol again. So let's sketch that out. Make it blue this to be the same. Okay, so something like that. And now state the intercepts and domains. So if we had our function here where x was 0, that would be y is equal to negative 2 times 0 squared minus 3 times 0 plus 2. Y would just be equal to 2. So y-intercept here is going to be at 0, 2. Our x-intercepts, I need to, maybe we'll go y-intercept. X-intercepts, I would say that y was equal to 0 this time. And I'm just going to drop the absolute value bars because it won't matter. So then I got negative 2 x squared minus 3x plus 2. And I don't like that negative out front again, like I said. So what I'm going to do is just divide everything by negative 1 or just move everything to the other side. So let's just divide everything by negative 1. If you do that, you'll notice that all the signs just change. So instead of a negative, you've just got positive 2x, positive 3x, and negative 2. So now let's factor this. So now if we do that, the numbers that we're looking for here, actually I can't really do that one because this value isn't equal to 1. So what we need to do is figure out our two numbers, and our two numbers need to multiply to negative 4, and they need to add to 3. So what about 3 and 1? And then positive 3, negative 1. Whoop, I meant 4 and 1. 4 and negative 1. There you go. Okay. So now let's write this with those numbers in there. So we've got 2x squared plus 4x minus 1x minus 2. We can factor out what we can here. So this is from this part. And then factor this out on its own. So we've got 2x and then x plus 2, and then factoring out a negative 1, we've got x plus 2, so our factors are 2x minus 1 and x plus 2. So our x-intercepts here are going to be, well, this one, if you solve for x, if you made that equal to 0, x would be equal to 1/2. This one, x would be equal to negative 2. So over here, this is going to be negative 2 comma 0. And right here, that's going to be 1/2 comma 0. Our domain and range, they're pretty easy. Domain is going to be x is any real number. Our range is going to be y is greater than or equal to 0. Now, just for the sake of time here, though, I'm not going to go through these other ones, but just notice that it's going to be a similar process. But when you factor this to figure out your x-intercepts, that's a difference of squares, right? you could factor this as x over 2 minus 3, x over 2 plus 3, right? So then we can figure out what our x-intercepts are from that. You'd make that equal to 0. These two, these are written in vertex form, right? That's not very good for factoring to figure out what our x-intercepts are. This is great for figuring out what our vertex is, but that doesn't really do us much good. So what you need to do is expand all of this. So let's say like this bottom one here. It's getting a little messy. This bottom one here, f. To expand that, remember, we need to write this out again as -3, and then that'd be x plus 2 times x plus 2 minus 4. And then we need to maybe put that -3 into there first. So we go -3x plus 6, and then multiply that by x plus 2. And then we need to FOIL this. So that times that, that times that. And then collect your like terms. And then you're in standard form, and then you can factor it. So that's kind of the tricky part about that one. So just make sure that you do that. Other than that, it'll be the same thing as what we were doing before, though. All right, moving on. Write the piecewise function that represents each graph. So the easiest way to look at these graphs is we can see that our invariant point, like where it flips, is when x is equal to 1. That's also our x-intercept. So if I'm writing this as a piecewise function, I would say f of x is equal to, and then my fancy brackets, and it's going to be equal to the positive version of this, right? 2x minus 2. That's this line right here. Like it would keep on going like that, right? If it wasn't an absolute value. So it's going to just be equal to 2x minus 2 when x is greater than or equal to 1. So when it's on this side of 1, it's going to follow the normal 2x minus 2. When it's on the other side, it's going to be flipped. So to flip it, I'm going to make it a negative. So negative 2x minus 2 when x is less than 1. And that'd be pretty much it. The last thing you'd want to do is just change that to probably 4 minus 2x. Or you could say negative 2x plus 4, either one. Okay, so that's how you do those. Yep, that'll be pretty much it for those. Okay. What piecewise function could you use to represent each graph of an absolute function? Okay, so let's look at this one now. So what I would do is say f of x is equal to fancy brackets. Now we're going to have 3 pieces, right? We're going to have 2 invariant points. So we're going to have, this side of the invariant point and then this side of it, and then in the middle. So to the left of it, that's doing what it normally does, right? It's just 2x squared minus 2. So it's going to just be 2x squared minus 2 when x is less than negative 1. So when x is less than negative 1. It's going to be flipped. That's what this whole middle thing came from, right? Because the original function would have been down like this, right? But we flipped it up, so the middle function, or part of it now, is upside down. So the way we did that was by going negative 2x squared minus 2. And that's going to be when x is greater than or equal to negative 1 and less than or equal to the next one, 1. Okay, and then the last one, it's doing its normal thing. So again, it's going to be 2x minus 2, comma, when x is greater than, right, when it's greater than 1. And then just close your bracket, and you're done. Well, probably change that middle one back to be like negative 2x squared plus 2 if you distributed that negative 1 to both of those. Okay, and then those are pretty much the same thing. With these, though, I guess let's do this one. So it's going to be, again, since the number out front of this is positive, right? This is the original function would have been like this, right? It's opening up. It's like a happy face, right? Um, then we could say f of x, and then open up our fancy bracket, is going to be just a normal function there, 3 times x minus 2 squared minus 3 when x is less than 1. It's going to be negative. Now, if you want to make it like a square bracket to kind of just keep it simple. And then 3 times x minus 2 squared minus 3 when x is greater than, oh, let's try that again. When x is greater than 1 and when it's less than 3. It's going to just be the same as the top when it's greater than 3. When x is greater than 3. Oh, and I probably should have had equal to on one of them there. Okay, so that'd be it. The last thing, though, that middle term, though, it just looks kind of weird. So let's just rewrite that as, I'm not going to do it again, but you could just distribute that negative into the negative 3 and then into that one. So this would just be negative 3 times x minus 2 squared and then plus 3. I'm not sure what the back of the book has too. Maybe the back of the book also expanded all of this and wrote it in standard form. I'm not too sure, but this would also be technically correct. Okay, I hope that was helpful. That's going to be it for that lesson.